Hello guys, welcome to my session today. Today we'll be learning about the init containers and sidecar containers. And before we go into the session, please do subscribe my channel and you can post in some comments if you require that needs explanation. And please subscribe to my channel. Okay. Before going into the init containers and sidecar containers, I believe you will be having a basic, I assume you have a basic idea of pods. If you are not aware of what the pods are and containers, please do watch my channel for the basics of the pods and containers. And this is for the persons who have knowledge on the pods. Okay, this one of the important concept over here for init containers and sidecar containers. Okay, this will be a demo session. So let's deep dive into the session. So coming to the init containers. So what are, before that, right? We know that the pod consists of, imagine this is a pod consists of the container one and then container two. Okay, you can just go on adding a lot of containers over here, right? So uh, init containers are nothing but a container. Okay, but it has a condition that in a pod there can be multiple containers. The init container, if init container fails, the pod will fail. Okay, the pod status will be failing. That's the reason. Please follow my mouse pointer over here. So this will be the init container and this will be the main app container. Okay, imagine you are having a web server over here, and before you start the web server you are just trying to check various conditions over there. And so for that will be the use case of the init container. Okay, in this session, in this case, init containers waits for some external service, and which is needed for the app container, which is an essential service. For example, no, init container will app needs a database, right? So database it will be a separate service. So init container can give you a if condition that if the service is available, then success, yes, it the flows go over here to the app container. Okay, if the init container times out or the service is not available, right, it won't start and it will time out and then it will fail. Okay, so that is the main advantages of the init container. Okay, so to recap, init container must pass to for a pod to be passing the control to the app container, meaning that so init container is the first container executed, and if it's failure, the pod will be like a failure, and if it's success, then the rest of the containers will be executed. Okay, so we will right now see the demo for the init containers. Before that, I have a piece of code over here. I assume that you are familiar with the pod concepts over here, and yeah. So I'll just explain. It's very simple piece of code over here. So I'm just going to do a deployment object, and I'm just win deploy like the name of the deployment, and then no. So you just concentrate over here. Okay, you just concentrate over here. So init containers. So see init containers. I need to mention with this key value like init containers. Okay. So this is a normal container. So this is a init container. So here what I am doing is I have a pod with two containers, one named as Nginx, that's a normal container, and then the init container named as init1. Okay, with the busybox latest. I'm just printing the hello world in the init container. So when the process runs, right, when the Kubernetes process runs, it will just check the init container first, and then if it's success, then it will go to the app container. Okay, let us I'll just show you a demo session. See, I have already the Kubernetes installed over here. Okay, so it's a kind cluster, and I have this Kubernetes running in the AWS environment. I'll just show the init file, whatever I've just shown you, explained you. Okay, I'm just going to apply it. Okay, apply init.yaml. Okay, init container. Get pods, kubectl. Get pods here, pod initializing. So slowly it will start up. Okay, it's running. Okay, so how do I know there are two containers are there, right? So you can just check the logs over there. You can put a describe pod and check over there, or if you just put like a logs, then you can see like default container, app container, out of app container, and then the init one, right? So two containers are there. If I just want to see the logs of this container specifically like init one, I can put like -c and then the container name over here. init1. So here hello world it's printed over here, right? So the container name can be get from here. So I have given mentioned like a init1. So this is the normal process. So what it did, it first checked the init container, then it went to a nginx container, I mean the normal container. It passed success. So right now we will try to fail this one. Okay, coming to our diagram. So this scenario, whatever we have tested over here, this scenario, whatever we have tested over here, okay, right now the init container is passing. Okay, so right now we will fail the init containers purposefully. Okay, so so I'll just delete the deployment over there. Kubectl delete -i init.yaml. Okay, delete. I need to ensure that no pods are running, and then I'll purposefully fail this init container. So if a init container is failed, the app container should also, I mean the pod should fail, right? So what I'm going to do is, there is a echo command, right? I'm just adding another one, o. So for purposefully telling like command not found, and then this container will not be started and it will fail the pod. Okay, so init.yaml. Okay, get pod, see error, oops, see crash loop back, right? Even though the app container is, even though the app container is success, right? So the init container, if it fails, the pod is will be in a failed status. Okay, I can check the logs over there. Okay, so -c, and then this init container name, see, echo not found, right? Now I will change the, I will restore it. Okay, I will restore it. Okay, now I apply it. Okay, it should sort like a charm. See, a new deployment is happening, or a pod is created. I mean, sorry, a new pod is created and the old pod, which is in a crash loop, will be terminated. Okay, so here running. Oops. So this scenario is like when an init container fails, it will fail this. See, I tested this scenario, so it started failing this one. Okay, so we will check in another scenario. The init container will be waiting for an external service, and the pod will be in a pending state or a init state until this external service is available. Okay, I already told you the use cases. Imagine this external service as a database service. Okay, let me do that. I just delete this old one. Okay, I have over here initial check. Okay, before that, I'll just explain you this piece of code so you guys will be aware of what I'm trying to do over here. Right now, our target is checking the external L check. Okay, so external L check. So here, so this will be my piece of code whichever I am trying to deploy right now. So it's the same. I have container. This is a normal container, Nginx container. Leave it. This is ignore it. It's like a app container. Okay. This is my init container. Okay. Right now, I am going to check an external service. Okay. Init container name is init check external service. I am using a curl image, and I am going to until curl. Okay. What this bash script does is it will wait for this service to get up and running, like my nginx-svc. I'll tell you, I am going to deploy this service. Okay, and then once the service is up and running, then only the pod will be in a success state. Okay, I'll just show you a demo. Okay, so first, no pod is there. Kubectl apply init l check. Okay, right now the pod should not be up and running. See, this will be in an initialization state. If you, because I have not deployed my external my nginx service, right? I have not deployed this my nginx service. Okay, if you check the logs also, it will tell like it is waiting for an external service. Okay, see, This is a very important thing you need to understand. Okay, I'm just putting like external chat. See, waiting for an external Nginx service up and running. So I'll just put like a tailf. So it will be just printing, no, until the service is up and running. It will be waiting for this one. Okay. Meanwhile, I have another one tab. So what I'm trying to do right now is I'm going to deploy this service. Okay, this is just a simple another one Nginx. I'm just created the service with this name. Okay, so I'll put the two tabs around here. Then it will be very helpful for you guys. So this first tab and this is the second tab. Okay, so I have this piece of code over here. Nginx. So I'll be deploying the service whichever this um, init container needs. I'm just going to deploy right now. Okay, Kubectl apply. Once I deploy that one, this messages after some time it will just go out and then the container will be. Before that, I'll just show you the container status. See, still in a initialization state, right? So once I apply this one, okay, I deployed the service, the dependent service. See, immediately what I mean, sorry. So this will be in initialization state. Slowly you can see that one. Slowly, once this service is deployed and then it's up and running, slowly this message will be going out and then see, and then the pod will be started. Okay, see, my pod has been started, right? So this is imagine this is an external service. Okay, so what is the use case we have just right now learned over here? So this will be the init container. This init container will wait for an external service which I right now deployed, and if it's not up and running, then it will just rotate. I mean, it will wait for a very long time and exit, and then I deployed the service, then it was success, then when it went into the app container, right? So that is the init container. So see, there will be a reason for everything, right? So what is the use case of the init container? So it will be waiting for the dependent service to start up, and you can do a warm-up catch for Redis. For instance, you people might be aware of a Redis catch for a frequently accessed website, right? The frequent web pages will be stored in a cache. So to warm up the web page, to warm up the cache, this can be used. And the third is like a Git clone. Before you do want to do any manipulations, you want to do a Git clone, and security checks and vulnerability scan, no, can be enabled here. The reason we are segregating the vulnerability scan is we don't want to give too much load on the main app container. Okay, so this also the secret from the vault. Secret from the vault is for a security reason. You don't want the secret to be extracted and stored in a file in an app container. So you just get the secret from the vault and then create a file, and then this container will exit. Okay, because no app container should not contain any like even the environment variables also for just for security reasons, right? So this is one of the use case. Okay, guys. Right now we will go for the sidecar container. So what is a sidecar container? Unlike init containers, sidecar containers, as the name suggests, run side by side, right? So app and sidecar container run concurrently. No matter it's just like a normal container, but it's like concurrently it will run. So it doesn't mean that sidecar container should pass and then the app container will be success and all. Okay, so it's just side by side it will run. Okay, so the use case for logging stuff, I'm going to show you a demo of logging. For instance, imagine this is a web server. It's trying to write a lot of logs over here, and then for it will write the logs in the volume, and then sidecar container will be reading the logs from the volume. So in a pod you can have two container, because see, I can read the logs from the app container, but imagine there are multiple users who want to read the logs from this container. The load will be very heavy, and the container will be in a crash loop, or the load will be high, right? So that's the reason we are using a sidecar container for logging, monitoring, security steps and all. Okay, so I'll just show you the sidecar container. Kubectl get pods. Let me delete this deployment. Delete hyphen. nginx.yaml init will check right now. I should not have any pods over here. Fine. So before this, okay, I'll just explain you that sidecar container piece of code. So the guys who don't understand, let them have this volume. Okay. So here, see, sidecar, unlike init containers, it don't have any specific keyword for sidecar container. It's just a containers. Okay, we are giving a name one, name two, right? So here, this will be like an app container. What it will do is like this script will just print the date in the var log app.log, just like while true, do date, then date, it will print the date for every 1 second. Okay, and then this is another one container like a log reader. It will just tail of the logs, that's it. Okay, and another one important thing to note that there is a volume I have created. Okay, volume is like an empty directory volume. So this volume will be mounted over here and mounted over here. It's like a common NFS share, you can imagine. Like, so for example, no, in your organization, if they are sharing a multiple files for you and your team, they will put in a shared drive, right? So that's the thing. So this guy will be writing rocks. Okay, I'll just put it in a different screen. So this is the volume. Okay, this guy will be writing the logs in this volume, and this container will be reading the logs. Oops. Let us check the demo over there. I have the piece of code over here. Sidecar. Okay, get pods. So see, it's 0/2 is two containers I have, right? It just telling it is running, right? Now I can see the logs of this one. This is my log reader, right? Log reader is my container name. So kubectl logs -c log reader. Okay, so here for every it's just this log reader is just reading the log file from the app container. App container is just posting this one in the volume and then this trying to read. I mean, posting in the file stored in the volume, and see this guy is posting the volume in this path, and this guy is reading from here. Okay, so this is the main thing you need to understand. Okay, so coming back here, so the use cases, just throw up this one. Use case will be like the logging stuff, as I told you, and the monitoring also, and security and data synchronization. Okay, the reason why we are using a sidecar container for reading the logs, right? So we want to just not put too much load on the app container because the performance issue will be there. That's the reason we are just putting in a sidecar container. Okay, so I just added here that the status over here like pending. I mean the pod status I have just mentioned over here, right? If it's like a pending pod accepted by the Kubernetes cluster and time spent for downloading the container images. So I just mentioned over here for like containers pod status is running means all containers are created. Okay, then pod status is succeeded means all containers in the pod terminated in success. Okay, and then failed containers or unknown containers. State of the pod could not be obtained. It's an unknown. It might be multiple reasons. This just for your knowledge sharing. Okay, thank you guys. Please do subscribe my channel. I'll be posting in a lot of videos related to Kubernetes. So please subscribe my channel. Thank you.